So I'm sorry that I missed out on yesterday. I've been not having good brain work days, just mostly like staring into space a lot. So when inspiration finally hit yesterday, I was like tapping out the script that I was hoping to record today, but then I stopped braining again. And I'm like, oh, I should really record another, or I should write one more video before I record. Surely I can bang this one out real fast. And I could not. I basically started an hour ago, finally. Like if I had started at 8 when I sat down at my desk, I probably would have had it done and had the videos recorded and probably edited and posted by now. But, you know, good night, everybody. The brain's just not braining. So instead, I've got like maybe half of the second video written. So I'll go finish that after this stream. Figured it's good that I'm taking a break. Oh, you know, I do have a much easier project. I remembered the other day to bring up a screwdriver. I couldn't remember if I needed a Phillips head or not. I do. So I can finally play with the other Christmas present I got, which is a little tiny working light bright. I don't know why they felt it necessary to make the battery. What? It's all right. Well, first of all, it's got batteries in it already. Wait, is that working? It is. Wait a minute. It is working. It's just like I only see like one. I'm going to replace these just in case. There's no way that that's as bright as this light bright gets. Come on. But I have the wrong batteries. This needs AAA. There are a few AAA batteries here, but why can't I do anything? Nothing is easy for me. And I don't mean that in a woe is me sort of way. I mean like what the fuck is wrong with me that I can't just like do one easy thing. I gotta make everything too complicated. All right, and with that in mind, let's get on to day 7. I think we're gonna learn some programming today. Whoops, I don't know what I just did. Sorry, you're gonna have to hear that again. Here we go.
Greetings once again from Rescue Shuttle Control.
Hello, Rescue Shuttle Control.
Great job. We have now determined that you are successfully acquiring analog data with your hero and responding to it with actions controlled by logic in the hero. That's exactly where we want to be in order to be able to successfully control the recharging of your batteries and get your shuttle up and running. So we are ready to take a big step today. We're going to build on your success from our last communication, and we're going to now add some more sophisticated logic and some more sophisticated control on top of what you've already accomplished. As we look at our work from our last session, we will not be changing
Oh, good,
analog
because I left it there.
circuits at all here. We'll keep our same photoresistor circuit that we had before, and we'll concentrate today almost exclusively on modifying our hero code. And the purpose of this, what we're trying to achieve today, is the ability to monitor and respond to the state of charge.
It occurs to me that I should since I'm starting to put these on YouTube, I should probably open all of these with like a little, hey Don Pedro. I should open these with like a little like, here's what I'm doing. So if you're watching this on YouTube, I stream more or less every day at 2 p.m. Pacific time at twitch.tv/RebeccaVersus. And we are doing a 30-day course in programming where I don't know how to program. So this is a little fun game where like my spaceship has crashed and I need to fix it to survive. And this man, if you can believe it, is my AI companion who's teaching me how to fix my ship. His acting is really great. You're gonna love it. So that's what we're doing. This is day 7. Yesterday we, as you can see down here in the the left-hand camera, this is our circuit board and our breadboard. Yesterday we made this light blink using this light resistor. It blinks faster the brighter it is. So other way around. Blinks slower the brighter it is. So when I cover it up, it blinks so fast it's solid. So pretty exciting.
Almost exclusively on modifying our hero code.
Also, we're going to do this again.
And the purpose of this, what we're trying to achieve today, is the ability to monitor and respond to the state of charge of our batteries, to be able to have the hero monitor that state in real time and report that information back to us over the serial monitor and to take appropriate actions. So that's our goal for today. And since we won't really be changing the circuit any, we should basically focus our attention on our code and see what kinds of new concepts and
we were right. This is a coding day
to accomplish our goals today. Let's start off by looking, as we often do, at the upper part of our code block.
Good thing I didn't delete this yesterday.
You will recognize this code that we used last time that defines these integer variable values for example, the sensor pin, the onboard LED, and so on. And we have our usual setup and loop routines. In the loop routine is the place where we were reading the analog sensor pin and then writing information out to the serial monitor. Well, we were writing to the serial monitor, and we were also flashing the onboard LED in response to that.
Yes.
Today we'll focus mostly on the serial monitor, not do too much with the onboard LED, since we've pretty much mastered that. And our focus today will be on sending data. So we have some new things that we're going to add today and introduce you to. We're going to introduce some new variables.
Yay.
Now, these variables are different.
Love me some variables.
You'll recall that an integer is a counting number. It has no fractional part. It's just 1, 2, 3, etc., or negative integers as well. In mathematics, an integer can have any value up to infinity or negative infinity. When we represent an integer on a computer, we're constrained because we are basically representing that integer by a finite number of bits. So, for example, if you only had 2 bits, 2 binary digits, you could represent.
You get a shave and a haircut.
0, 0, the number 1 with 0, 1, the number 2 with 1, 0, or the number 3 with 1, 1. So you could represent 4 different numbers with 2 bits, 0 up to 3. Similarly, if you had 3 bits, you could represent all the numbers from 0 up to 7. Last time we saw that we were basically getting numbers from 0 up to 1023. That would correspond to 10 bits.
Got it.
2 to the 10th power.
That's 5 shaves and a haircut.
Now, as it turns out, an integer,
it's not going to get old.
Here in our code can represent numbers up to about 32,000, plus or minus 32,000. If we wanted to represent a number bigger than 32,000, say 50,000, we'd need an additional bit. We can do that in this code by using a special kind of variable, and that is an unsigned integer. In an unsigned integer, we take the bit that's usually used to say whether the number is positive or negative, and use that to add extra range. So we could go up to 64,000 with an unsigned integer. So that's what we're going to do here. So I'm going to add to our list of variables an unsigned integer named battery capacity, and we'll set it to 50,000. So in some units, we're going to say that our battery will be full when it's reached 50,000. I can just copy and paste this. And we represent that with an unsigned integer. You can have some other variables here, an unsigned integer, which is the battery level. So we'll be watching battery level as it rises until it hopefully approaches 50,000 when the battery will be fully charged. We're also going to be keeping track of time as it goes by, and since we've been measuring time in milliseconds, it could be a pretty large number. So we'll represent time with the variable ticks here, which is also an unsigned integer starting at 0. Finally, we'll have an unsigned integer, which is just the value 100 milliseconds, and we're going to use that to change the amount of time that we wait before we do interrogations of the circuit. The reason for defining it here and not in the code is that if I wanted to change it to 200 milliseconds,
Are those
I could
equals?
change it in this
Those are.
notation and not have to go and find every place in the code where it needed to be changed. Now, you'll notice, before we move on to other parts of the code, that there's yet another variable type here, and it's called double. Now, up to now,
Come
we've
back.
been able to do all of our work using integers, that is, numbers that have no fractional.
This
or
isn't
decimal
on my
parts.
copy and paste
But
for some
now we're going
reason.
to want to actually be able to work with decimal numbers. And a good way to do that is to use scientific notation or exponential notation. That is, to be able to represent a number as some fractional part times 10 to some power. So for example, 30,000 could also be written as 3 times 10 to the 4th power. Now, numbers like that can also be represented in binary and can go to much greater ranges than is possible, say, with an int or an unsigned int. And so one of those types of variables is called a float. Float is just short for floating point number. That implies that it has a decimal point that can be anywhere. A float variable is capable of going all the way up.
I think I need to
plus
make
or minus
notes
about
again.
10 to the 38th power, which is a pretty big number. We probably work just fine with that
Hold
in
on.
the present example. If
Oops.
you needed more range, you could use an even longer floating point number called.
Okay, hold on. Double is for decimals, and float. Oh my God, go away. Hold on. I need you to back up a little there, buddy.
We probably work just fine with that in the present example. If you needed more range, you could use an even longer floating point number called a double. A double just has twice as many bits as a float does, and double is just short for double precision. So a double precision, or just for short, a double, can go all the way up to 10 to the 308th power. So that's a huge number, more than we'll ever need. And so we're going to go ahead and
Wait.
scientific notation or exponential notation. That is, to be able to represent a number as some fractional part times.
This
10
is
to some
confusing.
power.
Both are for decimal. Okay,
30,000
thank
could also be
you. Probe, you accurately identified my confusion. Oh, uint. Oh, interesting. Okay. Uint equals unsigned. Ah, float uses 32 bits, double 64 bits. Yeah, sometimes he talks about things in unhelpful to me ways. I think because I like to, when I'm learning something new, I don't give too much slack before if I don't understand something after a certain amount of time. Like I do this with books too. This is something I talked about in my review of William Gibson, I think, in Neuromancer. Like when I'm reading books, I expect if I'm thrown into something in situ, like you're not immediately going to understand everything about what's going on. So you give it a certain amount of time. And I feel like maybe, I don't know, I'm trying to compare it to what I imagine other people give, and I assume that it's less time, but maybe not. I think I know this is ironic for someone whose whole thing is skepticism, but I'm uncomfortable with not understanding fully. So I tend to get more and more nervous as time goes on, which is why there have been several times during this where I've stopped it because I'm like, well, hold on, I'm not fully understanding that. And then I'll like hit play and then he'll explain it later. Yeah. Yeah, and probe, and this is something that came up before with just like the idea of like, voltage and resistance and current. And somebody said that before, like, that's you don't need to know that yet. And it's like, well, maybe not, but I do already know it. Like I've heard it before. So I just want to make a note because maybe this is explaining it in a better way and I want to understand it. So yeah, like I don't mind knowing a little too much, but yeah, like he might not be explaining it the yeah, like why not start with float and then double? But okay. But no, I do appreciate you guys helping out with this stuff. Like, I would probably be way more frustrated than I am.
It's 3 times 10 to the 4th power. Now, numbers like that can also be represented in binary and can go to much greater ranges than is possible, say, with an int or an unsigned int. And so one of those types of variables is called a float. Float is just short for floating point number. That implies that it has a decimal point that can be anywhere. A float variable is capable of going all the way up to plus and minus about 10 to the 38th power, which is a pretty big number. We could probably work just fine with that in the present example. If you needed more range, you could use an even longer floating point number called a double. A double just has twice as many bits.
Yes, yeah, I would have explained that in the opposite way, precision. But okay.
So a double precision, or just for short, a double, can go all the way up to 10 to the 308th power. So that's a huge number, more than we'll ever need. And so we're going to go ahead and
that's more than double
precision for our non-integer number here. In this case, we're going to use the double precision variable %full to...
Hold on, I'm making another note. IEEE754. Okay. I'll keep that in mind, thank you.
To basically calculate how close our battery is to full. So if it says 54.3%, that will tell us how close we are to having a full charge on our batteries. All right, so that's a little review of
all right, so
types
double equals percent full.
The next thing that we want to introduce ourselves to is the idea that we're not restricted.
Oh, and I haven't been using my semicolons.
Routines in our code. We can actually define our own functions and use those, say, in loop. How would that work? Well, what I'm going to do is I'm going to keep our original setup, and you'll recognize what setup did from our last session. In this case, setup just did 2 important things. It set pin mode for our onboard LED to an output so that we could flash it on and off when we wanted to, and it started up the serial monitor. So that will not be changed, and we'll keep that the same. What we're going to do now is we're going to introduce a new function, and we will just put that in here after setup. That's a convenient place for us to put it. So let's go ahead and put this new function in.
Oh.
Let's have a look at what it does.
New function.
Space here so that it doesn't look like it's part of setup. All right, you'll notice that this new function has a name, and its name is print battery percentage. Void is just a way of telling us that this function does not actually return a numerical value, it just does something. Print battery percentage does what's inside these curly brackets between here and here. So let's just read through it and look at the comments and see what it does. The first thing that print battery percentage does is it prints the value of ticks, which you'll remember is just whatever the time is that's elapsed so far. And you'll wonder, how does ticks get changed? That will...
Once again, my my copy and paste is not quite right, so I assume he'll be changing these things later. It would be nice to have a copy and paste that's goes along with him, but that's okay. I guess I do like typing it all out, like I've said before, so I guess it's not the end of the world. It's just a little annoying for you guys because you have to... My K button doesn't really work, my K key. But you can also spell ticks like that, so... all right, and then it's... The other problem is that this is a little small. And his mouse is in the way.
Be discussed shortly. Next, we print to the serial monitor a little caption that says milliseconds, then puts some space in, and it says charge at space. Now, what's going to come after that? Well, what's going to come after that will depend upon how much charge has actually accumulated. So what we're going to do is when we wait for a certain amount of time, current times time is equal to charge. So if we wait for a fixed amount of time, then that multiplied by our measured battery value will basically tell us how close we are to battery capacity. So let's take battery level, divide it rather by battery capacity, and then multiply that by 100. That will be the percentage that battery level is of battery capacity. Multiply it by 100 and it becomes a percentage. Now, let's print out the percentage, and that will just come out after charge at. So it will tell us what the percentage is. And finally, print with print ln, which will basically end the line and return the percent symbol. Okay, so we're going to do that repeatedly. So we
it's
make
a lot.
that into
It's a lot happening here. All right, double battery level, double battery capacity. Okay, so it's 100 times battery level divided by battery. Is that right? We're dividing? That's what slash means? I mean, I know it's what it means.
So let's take battery level, divide it rather by battery capacity.
Okay.
And then multiply that by 100. That will be the percentage
Right.
the battery level is of battery capacity.
And then
multiply it by 100 and it becomes a percentage.
Serial
Now, let's
print
out
line. I know
and
that
will
that's
just
an
come out
L
after
now.
charge at. So it will tell us what the percentage is. And finally, print with print ln, which will basically end the line and return the percent symbol.
Oh, he finally said
We're gonna do
LN.
that repeatedly. So we make
Maybe
that
he
into a
did
function
before
we
and I
can
just
call whenever we need to do it.
didn't
All right,
hear him.
that's pretty good. And now we have to focus our attention.
All right, I
on what's
probably,
happening
let me,
in
I'm just
so
gonna
quite a bit is going to
verify that I have, nope, missing terminating character. Oh, so, okay. So I've got that correct. That's correct. Oh, I thought that was a, okay, so I thought that this after 100, I thought that was a quotation mark and that it would automatically multiply because it was next to a parentheses. So no, okay, so that's multiplication, not that. I'm probably going to have to like pop out the video at some point. All right, and then serial print. That says percent full, but I'm pretty sure he's just got a percentage mark in here. Let's try compiling that. All right, I've got another unqualified ID before the equals token. It doesn't like, oh, there is no, wait, he doesn't have an equals hold on. Oh, he doesn't. I see, because double is like unsigned integer. You don't put an equal sign there. See, this is this is my other issue. Like, grammar matters. I feel like this is kind of like learning Spanish on Duolingo, where like you're learning the vocabulary, but you're not necessarily learning the grammar. But you know, grammar is really important. All right, and then I've got another error, percent full. Oh, because I didn't capitalize the F. Again, it's important. And I don't know why, like, there we go. All right, compiled, clean. I don't know why, like, so if I were a little kid doing this, I wouldn't necessarily understand this like, I don't know if he has a single time. He might have said it at the beginning, which is how I knew it, like offhand. Like, you click verify to make sure that the code is grammatically correct before you upload. Every other time he's been like, okay, and then let's just upload the thing. It's like, hey, Misty. Oh, sorry, hold on. I missed a few comments while I was doing this. Faith-based programming. Oh, IEEE. Oh, I do want to sound cool. Hi, Ty. Oh, yes. I guess syntax is the right word, not grammar. Hey, Ryan. So yeah, like again, if it were me running this course, I think I would be like stressing like the grammar. I don't think he's ever mentioned the thing about capital letters, faith-based programming. So yeah, like I would be like, hey, there's this simple tool. You click this little check mark and it will verify that your code syntax is correct. If it's not, it'll tell you what to fix.
Void is just a way of telling us that this function does not actually return a numerical value, it just does something. Print battery percentage does what's inside these curly brackets between here and here. So let's just read through it and look at the comments and see what it does. The first thing that print battery percentage does is it prints the value of ticks, which you'll remember is just whatever the time is that's elapsed so far. And you'll wonder, well, how does ticks get changed? That will be discussed shortly. Next, we print to the serial monitor a little caption that says milliseconds, then puts some space in, and it says charge at space. Now, what's going to come after that? Well, what's going to come after that will depend upon how much charge has actually accumulated. So what we're going to do is when we wait for a certain amount of time, current times time is equal to charge. So if we wait for a fixed amount of time, then that multiplied by our measured battery value will basically tell us how close we are to battery capacity. So let's take battery level, divide it rather by battery capacity, and then multiply that by 100. That will be the percentage that battery level is of battery capacity. Multiply it by 100 and it becomes a percentage. Now, let's print out the percentage, and that will just come out after charge at. So it will tell us what the percentage is. And finally, print with print ln, which will basically end the line and return the percent symbol. Okay, so we're going to do that repeatedly. So we make that in.
Hold on. I just want to make sure I'm looking at the right thing. So ticks, and then ms, and then, oh, he's got I'm just putting an extra space in here, and then actually, yeah, I thought this was, oh, I'm missing so after battery capacity, I'm missing a serial print percent full, and then serial print line. Okay.
To a function that we can call whenever we need to do it. All right, that's pretty good. And now we have to focus our attention.
Ryan, we are working on the computer telling us our battery's percentage.
Happening in loop. So quite a bit is going to change here in loop. As I mentioned, we're going to de-emphasize for the moment the flashing LED function and focus more on what kinds of information that we need to get from our circuit, through the analog pin function, and what actions that we take in response to that. So we're going to replace this loop function now with a new loop function that's a little bit complicated. So we will take our time in stepping through it.
I hope that this is close then.
Understand just what it does. So let's go ahead and put that in and have a look at it. All right, so as we start loop, the first thing that we do is we do something that should be familiar to you from our last session. We measure, using analog read, the value of the voltage at our sensor pin. Now, we assign that to the variable sensor value, which you'll remember is an integer. It's going to be some integer value between 0 and 1023. And rather than just taking that value and doing nothing with it, what we're going to do is we're going to add it to the previous value of battery level. And that uses a new construction that we're seeing right here. Battery level plus equals sensor value. That's just shorthand for take battery level, add sensor value to it, and put it back in battery level. That's what this statement does. So
okay,
you
that
can
makes
think of
sense.
every time an execution of loop occurs, battery level will have added to it however much the current sensor value is. So it'll just constantly be going up and up and up. And the rate at which it goes up will depend upon how bright the light is that's falling on our photoresistor. So we should see battery level rising rapidly when the light is bright. We should see it rising very slowly or not at all when the photoresistor is dark. So we'll be looking out for that when we test our code. All right, so once we've done that, we're also going to say, okay, the time has just gone ahead by 1 wait time. So let's take ticks and add wait to it and put it back in ticks. So that's what's meant by ticks plus equals wait. So battery level's been updated, the time has been updated, and so now let's go ahead and do a test, a logical test. If battery level is greater than or equal to battery capacity, which another way of putting that is if battery level is greater than or equal to capacity, we've reached 100%. And so what we're going to do is print out ticks, the current time, milliseconds, and fully charged. So that will be printed out instead.
PHP is the only other language besides HTML and CSS that I have any hands-on experience with, really. I'm trying to remember if I ever messed around with JavaScript. I don't think so. Maybe a little bit, but PHP, because when I first started Skeptic, well, when we reached the point where I needed to get my own server, I had to do my own PHP monitoring and stuff. And my God, what a goddamn nightmare. Like, learning anything was just, it was very difficult for me. And I broke a lot of stuff. But then I fixed it. So I'm kind of proud that I managed to keep the site running for several years. Occasionally turning to friends who are programmers for help here and there, like if something really went wrong. And then I finally found a managed host that takes care of it all now at great expense. But yeah, basically I pay $300 a month to not really understand PHP.
The normal thing that will be printed out if we haven't reached 100%. So if we haven't reached 100%, then nothing will happen inside these curly brackets after the if. Instead, what will happen is what's after the else. And what's after the else is print battery percentage. Our function, our custom function, which you'll recall, if you go back up here and look at, simply reports the current time and the current percentage of charge. So there's two possibilities. One is that we'll just simply print the current time and percentage, or the other is that we'll declare it fully charged and then just zero out the time and put in a really long delay so that it will just sit there for a long time and say fully charged. So that is almost finished. You'll remember that, of course, once we reach the end of the loop, we just go back up and start again. We don't want to immediately start up again because we want to wait for our specified period of time, which in this case was 100 milliseconds. So we put in a delay of wait, and then off it goes to make the next loop. All right. Hopefully, that's a fairly clear explanation of what our new code is going to do.
Crystal clear,
We're just
sir.
about ready to give it a test. This is some fairly extensive modifications that we've made here. So let's just check it and see if it compiles.
Oh, there you go. You finally did it.
And we made a mistake. We've got a problem. It says it's expecting a semicolon before this curly bracket.
He made a mistake.
I forgot to end this delay statement with a semicolon. So I add that semicolon, save the change.
I remembered it.
Compile it once again.
Just kidding.
Compiling. It worked this time. So I caught an error there before I caused problems for me. All right. So once
Cadbury.
We got the code correctly entered.
I recall considering that.
Monitor so that we'll be able to see just what's coming out of the hero once we begin operation. I've got my flashlight handy so that I can check to see what happens when I increase and decrease the light illumination on the photoresistor.
All right.
So let's go ahead and upload the code.
Oh, it's charging.
To finish uploading.
Yay.
It does. You should be able to, okay, it's done uploading. And we now have updating information. You can see right now that the charge is slowly rising, 7%, 8%, 9%. What happens if I shine the photoresistor on it? Oh, now it's going up much more quickly. I take the flashlight away,
Oops.
go back down to a slow rate of rise. Flashlight back, now it's charging rapidly again. We're all the way up to 50%, 60% almost. There we go. Back down. If I cover it up,
it's oh yeah, it is. It's just going by tenths, so I'm like, it's still going pretty fast, but no.
So let's go ahead.
Oh yeah, cool.
Let's let it finish.
It's working.
75%. Let's see if our logic successfully works to stop it. And 97, 99,
Oh,
fully
this
charged.
is
So we have
no, that doesn't work.
in achieving what we wanted to achieve.
I guess I should
So
also
this is
figure out a way to show you guys the
the
programming window, but
output of
whatever.
information.
It looks
telling
like
us,
his.
what the state of charge of our batteries are. And with some added logic, we could do additional operations. We could presumably control analog or digital pins on our
And now it's
Hero
fully
that we
charged.
might use to turn on or turn off certain circuits. So hopefully you can see how useful this is going to be to us. We are now really making great progress. We're learning new techniques, both in terms of the processing of data and in being able to make logical decisions so that the Hero can automate processes for us. So with that, we will
Really,
end
Ryan?
today's session. You can go ahead
That's
and practice
hilarious.
this. Customize the code on your own to perform similar or different functions.
Yeah, just trust
until next
me.
time, remember that
Oh.
you want to build everything and
He forgot his own slogan. I've heard of Pearl. I didn't realize it had its own religion, but I believe it. I have. He forgot. He has one job. Oh, he's not good at the the acting part. It's funny that you say stay away from Pearl, because when I first started reading Riven's comment, I really thought that where you were going was to say, like, you should stop doing this and learn Perl instead, because one thing I noticed early on as I started dealing with more and more programmers, it literally started with when I first launched Skeptic, I decided to use WordPress. It was just, I checked out a couple of different options. I liked the way WordPress looked. As somebody who knew HTML but wasn't very good at CSS and didn't feel like learning a lot, it was easy for me to like dive in and get things set up pretty easily. And then as we grew, I started looking for people who would be interested in, designing like a more professional looking website. I was just using off the rack WordPress, like their standard bloggy looks. And almost immediately, like I got this guy, it was a guy who came to Boston Skeptics, and I married one, unfortunately. But he immediately took a look at it and he's like, okay, well, first things first, we're going to switch you to Drupal. And I was like, but I don't, why? And he's like, because it's better. And I would later learn, like, I was like, oh, okay, let's switch to Drupal, I guess. So we did, and it was a fucking nightmare. And eventually I had to tell him, like, look, what you're doing doesn't look good enough for all of this all these problems. So thank you, but no thank you. I'm good. And like, I was paying him, So that was my first introduction to what I saw happen repeatedly. And so later on, I started dating a guy who worked for Center for Inquiry. And they had this in-house guy who, his name is John, and he was their in-house developer. And my boyfriend told me, like, yeah, when John first came on board, he was like, what the hell are they doing? Having the whole website written in like in such and such. I don't remember like what languages they were, but he decided that he wanted to learn a new language. And so he went about completely changing the way the whole company operated to be on this new language. And then after a few years, he left and a new guy came on and he's like, what the hell is this language doing here? I'm actually really curious about this new language, and I'm going to learn it by switching everything over. And that's what he fucking did. And I'm pretty sure that that's what the guy before John had done as well. Hey, Trick. And I just fucking love that. Like, this, and like nobody at the company, like, the guy I was dating was also a bit of a programmer. So he saw all this happening and thought it was hilarious. But it's like, what's the rest of the company going to do about it? Nothing. Nobody else knows what's going on. So, like, they just kept getting these developers who came in and basically treated it like a student working situation. Like, I'm a bit of a programmer myself. That's me now. That's me. Yeah, like I'm going to use this job as, I'm going to learn on the job. It's just an opportunity for me to learn this programming language. Did it. That's really funny that Perl is so hated in this chat, at least. Right? And so, yeah, now I get it. I get the programmer mindset. And I love, like, every time, like, you show a programmer a bunch of code, like, the first thing they're going to say is, like, what idiot wrote this? And then they'll, like, look at the comments. It's like, oh, yeah, I wrote this. Like 2 years ago. What a fucking idiot, you know? And, you know, and now that's going to be me. Follow me on GitHub, everybody. And, you know, we'll learn together. Okay. Oh, color. All right. Looks like we get into a little bit more wiring tomorrow. Maybe some more programming. I don't know if I have the time right now to add in this kind of learning, but I might need to, like, just pick up. So wait, this is C+, is that right? Or is this C? I never remember the difference. I mean, not remember. I never remember which we're talking about. It's actually wiring? What, that's like... Oh. Really? Like, this language is just called wiring? With a capital W? I didn't even know that. I had no idea. I thought the wiring part was this part with the wires. Huh. And you say it looks a lot like C, and Empty saying I use C++. So wait, Arduino understands any of this. Basically C. Oh my god, you guys, I feel like you guys make this stuff purposely confusing. I'm making a note here. Wiring /C/C++. Oh. So Arduino just speaks its own language. And we use a program to translate it from what I want into what Arduino. Oh, thank you, Ryan. I'm making another note about that. Perl human genome. Hi, Gliderino. Learn what it is I'm trying to learn. Oh yeah, I know how to code. Really, what language? I don't know. Sprechen Sie Deutsch? Oh, yeah, any code into a compiler into binaries. Right. What is IDE? I hope you guys are enjoying Twitch teaches Rebecca things. Integrated development environment. Okay. Bracket Sie Deutsch. Sprechen Sie Deutsch. Look, I don't sprechen Sie Deutsch. Look, yeah, I'm not even good at human languages. That's what we're up against here, you guys. You didn't think this was going to be easy, right? Ah, okay. Tiny shitty IDE. I mean, it was free, so I wouldn't expect. Do you, Darth? Well, I don't. I don't sprechen Sie anything. I barely sprechen Sie English. I mean, yeah, ich sprechen English. Which reminds me, do you know that my partner is, yeah, I was about to come back to that. My partner is now on like day 500 or something streak of learning Spanish. And every time I overhear him do his lessons, I'm reminded that I had this plan to like take in-person lessons or something so I could like hurry and catch up, because I know Duolingo is in no way the best way to like learn Spanish quickly. So if I commit myself, I'm sure I can catch up. But every day I hear him do it and I don't sign up for lessons. That gets like further and further away. But I was also reminded, so I'm a very deadline motivated person. And the other day I was reminded of a Spanish speaking deadline that I had kind of set for myself a year or two ago, which is approximately 1 year from today. There is going to be an eclipse, and I really wanted to go to Mexico to see it. And I like to know some of the language before I go to a country where English is not the first language. And wouldn't it be nice if I knew more than just hello, thank you, goodbye, water, beer, please? So, I don't know. Maybe it's time for me to set up a new goal. We'll see. Oh, and speaking of goals, I have another update. Climate Ride has just announced their dates for Death Valley. So I'm pretty sure I'm going to do it. The only reason I didn't sign up today is because the friend that I want to do it with is on the East Coast of the US and has something happening the day before the race's start date, and the airlines aren't yet selling tickets, so he can't guarantee that he can fly in time for a few more weeks. So in a few more weeks, I will know for sure whether or not I'm going to be riding my bicycle through Death Valley this fall. I don't know. We'll see. I'm getting kind of excited about the idea though. So, yeah, if I do the bike ride, I mean, there's only so much I think I could yeah, I don't know how the Wi-Fi situation is. But because it is, hey bud, what's going on? Hi. What's up? Yeah? You got a big stretch in you? Did you hear me kind of wrapping stuff up? Do you want a treat? Let's see. You're not on camera. You got to back up. Good boy. Sit. Good boy. Beep, beep, beep. Good boy. Here you go. There you go. So yeah, like the climate ride is a, it's a fundraising thing. So yeah, if I do it, no, I don't have the kit yet. There's one more bud. No. I can't even, I'm not even at the point where I can use my clip-in pedals. So yeah, like there'll be a bunch of fundraising and stuff that I have to do as part of it. So you guys are going to hear way too much about this bike ride if it happens. Way too much. So, I mean, I've long had Don Pedro clipless pedals, but I used to use them in and around like Boston, but then I moved around a lot, and then I replaced them because I just wasn't cycling as much. I wasn't as hardcore. So I got some pedals that are both clips on one side and regular on the other side. And for the last 7 years, maybe, my clipless shoes have been gathering dust in the closet. I don't even know if they're going to fall apart when I put them on. So, yeah, there's a lot of work to do. But yeah, it might happen. I'm kind of excited about the idea of it. So we'll see. I'll let you guys know. All right, I'm going to go finish up writing that video, and maybe, I don't know, I might try to record today because I am a bit behind this week. So thanks for joining me. Thank you for helping me learn wiring/C/C++. I very much appreciate it. I will see you guys tomorrow. Peace out.